But remember, we talked about sets, talked about function. We talked about function notation. What is a function? That's important right there. What is a function? Okay. It has to pass the vertical line test. Has to. Okay. For us, it has to pass the vertical line test. It does not mean, okay, now hear me out. Does not mean that you may see stuff on its side, like over here. Okay, you may eventually graph stuff that's on its side. Doesn't mean it's a function. Okay, just means it's graphable. It also still means that it has a domain. It also means it has a range. Okay, I want to make that very clear. Notice not everything's always separated with line or not joined together by lines. You can also have a function of just points. Okay. We have linear functions. Notice, but to create a function, remember, it's a shape. This is a linear function. We're going to get into the linear functions today. But that's a line. You've seen them. That's y equals mx plus b. Okay? When you're turning something into a function, you're solving for y, and you're changing the y into f of x. Remember that from yesterday. Okay? And then because what that does is that opens up a world of possibilities. Instead of solving for a point and finding a point, now we've made this a function, just like my pin analogy. When I throw a pin, I can now start taking this pin at time 0, time 1, time 2, whatever, okay? Or whatever it is that we're mapping at the time, okay? I showed you this one, okay? Just basically, remember the x value is the guy that's inside the parenthesis. Don't get hung up on f, okay? I'll be honest, like I said, you guys are a lot smarter than me. I had such a disconnect, and I did this class extremely fast, just like you guys are doing, okay? And didn't really delve into the nitty-grittiness of college algebra. And I would see f of x and think, okay, that's that function. And then all of a sudden I would see g of x, and I'd be like, well, what's that then? Not realizing they're both functions, okay? It's just we can't have two f of x's, so we might have to differentiate things by just different letters. Okay, you'll see that when we start combining functions, okay? Because we can take this function over here, and put them together, okay? But remember at f of -2, you just go to the -2 value and then see what's happening with y. I want to say that because I think especially in this next one, it may say to you, hey, can you create a line from just this functions that we're giving you? Well, yeah, you're given points. Which is why, remember, I taught you back in this last one, you have the point slope form, you have those other things. So you still have some points on there that you can look at, okay? It's just now they're differentiated a little bit different. And then, of course, like I said, don't stress too much on this. You're never going to see that on a test. This is more for the 1% of students that are probably going to go into a higher math. But remember, I'm trying to give you a good foundation of what functions do. Okay, but this is a good prelude to start talking about what implied domain is, which is literally every function. Let me put it this way a little bit different. If I give you something of the form y is equal to something, you're never going to solve for a restriction. When you solve for that guy, okay, hence solve for it, okay, you're not going to end up with a restriction. You're just going to end up with an answer, okay? But functions you're not solving for a function. It's not saying, well, let me get f of x by itself. No, f of x is defined as this equation over here. And f of x says, you're no longer solving for me, you're giving me values. Okay, you're dumping things into this machine, which is why we have these implied domains. Because at some place, those functions are going to break down and not work. Some of them work all the time, like a linear. Think of a line. A line has infinite domains, infinite range, depending on how the line is, of course. Okay, does that make sense? So no matter what I put in there, I'm good. Okay, and we're really looking at the domain. Okay, domains are where the restrictions come from. But on this one up here, the very top one, I have the square root of a number. Square root is an even radical. An even radical can't be negative. So that function, it doesn't matter what's happening around it. Okay? There could be an x squared over here. Let me just kind of give you a little hint. That could not say the square root of 4x plus 24 plus 3. we could literally change this to this right here, plus x squared, and still the implied domain would be that guy right there. Okay? Because the x squared does not have a restriction. You can give me any number you want for a parabola. Doesn't matter. Okay? So now, little caveat, there are times where you may have two things happening, okay? I do not believe they're happening in this homework. I think they happen toward the end, where you might have something as the square root of 4x plus 24 plus 2 over 3x. Notice what you have here. That guy's got a restriction, doesn't it? So does that guy. You combine, that's when you start combining functions. You start going, okay, what is the total, so you kind of just have to start graphing, find out where the intersections are at. Okay. It's easier than what it looks like here in a little bit. Okay. Everybody good with that? Okay. And then of course we ended with, did everybody get that one? Okay. I don't want to leave this area without you understanding what I did here. Forget the whole limit thing. We're not worried about that. But do you understand how I replaced all of that to create the bigger thing? Or do you want me to go over one more time? I don't mind going over it again. We got time. We go over one more time. Think of this as two separate functions. Okay? Two complete separate ones. Okay? So one of them, the first function is going to be defined as this. F of x plus h. Okay? That's all it says. Now remember, let me kind of come over here to the other side. If I said this to you, hey, what is f of 1? Well, wouldn't you just come in here and put 1 squared minus 6 times 1 plus 2? You all get that okay, just right? Well, you're doing the same thing here. I'm just going to replace every single x with that. That's all I'm doing. I'm replacing whatever's inside the parenthesis with every single x value. So sometimes it helps to kind of write these separate before you bring them together. Okay? So notice this first one is going to turn into, well, notice I have x plus h squared. There's that. And then I have minus 6 x plus h, and then I have a plus 2. Now let's be honest. At this point, if you wanted to, you'd need to go ahead and come in here and take this one right here and go, okay, well, this is going to be x plus h minus, we can go ahead and FOIL that, right? We're just extending it out right now, right? So then I get x, and then I get what? Plus xh plus xh plus h squared, okay, minus 6x, oops. I messed up on that one right there, didn't I? Because I'm carrying that negative in there. And then I get minus 6x plus 2. Combine it all together, and you get x squared plus 2xh plus h squared minus 6x minus, 6h plus 2. Well, that's all been pulled together, right? Nothing else can be put together. Everything's been simplified. Now, notice what the back end of this guy says. It says right here, minus f of x. Well, they already gave me f of x. Isn't that f of x? It already gives me that definition of f of x. But it's saying I have to subtract that. So the moment I put this subtraction is why yesterday I said, hey, don't forget to put that with a parenthesis. Okay, and then you've got x squared minus 6x plus 2. And don't forget, this whole thing is obviously over h. Okay, does that make it a little bit more understandable now of what we did? You're just replacing that into there. Now I get it. I promise you. You're sitting here thinking that maybe I'm trying to dumb this down. I'm not. It's easier to do with numbers. It was so much easier to put that 1 in there. Okay? It's because you're seeing only variables and you really want to solve for those. Your innate ability is going, I just want to get rid of all those variables and let's just get to a number. That's not the case in this scenario. With functions, what we're doing is we're trying to create a new function that's going to help us with something. For this one, it literally turns into, this is literally chapter 1 in calculus. Okay, is learning the difference quotient. Okay, because this is literally a calculus problem. Okay, but they're teaching you in algebra how to take a function and replace it in there, how to take something here and put it into the equation. Okay. And then, of course, you can go back into the notes and see how a lot of the things cancel out. Don't forget to pull out the h. Okay, so that way you actually lose the fraction. Okay. A little better now. Practice, obviously. Okay. Any questions over it? I don't want to just gloss past it. Okay. But also don't overthink it as well. Okay. These type of problems aren't something that's going to come up a lot right now. Okay. This is just a skill to have to say, hey, whenever I have a function, whatever's inside the parenthesis, that is what is replacing every single x inside the function every time, no matter what, moving forward. Okay. No matter how ugly it is. Okay. Reason I want you to get this is because when we start learning the properties of functions in chapter 4, is it chapter 4? Maybe chapter 3. No, it's chapter 4. You're going to need to understand that if I have a function here and a function here, if I want to add them, what do I do? If I want to divide functions, what do I do? This is why you've learned about rational expressions. This is why you've learned about why do I got all this ugliness on top and all this ugliness on the bottom? Well, because both of those are functions. And you've already been doing the math of these functions since intermediate. We're just now turning them from y's to f of x. But we all know it's really the same thing. Only difference now, but since we're dealing with f of x, you got to be careful of restrictions at all times now. Okay. Or implied domains is what we're really calling them. Okay. Better? A little bit? I didn't muddy the water. Okay. Let's jump into 3-2. One, super easy for you. Linear functions. Linear. You like that? Slope-intercept form. Except instead of y is equal to mx plus b, notice what we got here. Let's look at the definition. A linear function f, does it have to be f? No. No, it can be g, it can be h, it doesn't matter. Okay. In the variable x is any function that can be written of the form f of x is equal to mx plus b. Okay. Where m and b are real numbers, we know what those are, any number. If m is equal to 0, okay, oh, m cannot equal 0, okay? It's also called a first degree polynomial. Okay, obviously, remember I talked about that? How do you know that? Look where the x is at. It's a first degree. A first degree, and I really need you to start listening in today about this specifically. You gotta start paying attention to those. Okay, if you can remember that this is a first degree polynomial and it creates a line, I promise you when we get to chapter 3, you're like, oh, that makes a lot more sense. Because after we get to when we get to chapter 3, you're gonna start learning about all the functions. Okay, except for logarithms and exponentials, that's chapter 6. Okay, but other than that, pretty much every single function we can think of. Okay, their base function, not the really wickedy ones that go all over the place, but we'll learn about what that function looks at as its base. Okay, so we can kind of tell its behavior, its shape, just by what the base function is doing. Okay, so you can tell that no matter what happens, if I have f of x and there's only a power of 1, it's going to be a line. Okay, it's either going to be a straight line, okay, or it cannot be an up and down line, can't be a vertical line, because remember that's undefined. Okay. So, because remember, that wouldn't be a function. Okay. So consider this one right here. We have considered the function f of x is equal to negative 3x plus 5. Figure 1 contains a table of forward ordered pairs. I didn't give you those because we're going to make our own. It's no different than what you did before. First off, let's just be honest. Do you see 2 points, or do you see a point right now? Yeah, there's a point right there. There is no difference in what you learned when you were learning y equals mx plus b. We've just changed it. So I know one point right now that I can just go ahead and just give is going to be 0 and then go up to 5. Now, if I'm using this type of function, what could I do now if I wanted to find more points? Do I have a slope? The slope says what?
Go down 3 over 1.
Yeah, go down 3, 1, 2, 3, and then over 1. There's another point. Couldn't I go down again? Down 3, over 1. Down 3, over 1. And notice I found my 4 points. Now that was easy, right? But let's work this out mathematically as well, just real quickly. So when you start seeing the notation, you're like, what? We've been doing this the whole time, right? We just come up with x. But instead of putting y, I'm putting f of x. Because f of x does equal my y, doesn't it? Just change the notation. And so notice, yes. Now if I come here, if I want to find more points, I could come here and say, well, what happens if x is -5 or x is 5? Let's find out. X is 5, I would come over here and put, okay, when f is 5, you get -3 times 5 plus 5, which is obviously going to give us, that's -15 plus 5, is going to give us what? -10. So 5, -10. Which I could have obviously found by doing my slope, obviously, but notice 5, -10 would be right here. Works either way. Now, what that is nice because it's a slope and we can kind of graph those pretty easily, okay? But remember, you may be asked to do, not graphing, but you may be asked to find points, okay? And they may not give you a graph. So it's always still good to keep this knowledge possible right here of being able to do your little chart, make sure to be able to go through there and do that, okay? So you know it's a linear function by what? What is it going to be?
First degree.
Right. First degree function. There is no power in there whatsoever. Well, okay. All your powers are 1. Okay. Should you get hung up with x and f of x? It could be anything, right? It could be g of t. But we're looking for something. The g would be where the y-axis would be. Okay, the t would be the x-axis. Remember, whatever is inside this is your independent variable, because f is dependent upon whatever x is. Okay, that's why it's saying f of x. Basically, it's saying that y-axis is now that f of x. Okay. Good so far. I mean, lines kind of done this before. This one right here. Find the formula for the linear function. You can do this a lot of different ways. You have all the knowledge now. One way you can say, hey, do you see a y-intercept? Okay. Well, my y-intercept is what?
0, 4.
0, 4. Don't forget, y-intercept is always a coordinate point. The reason I say that because Hawks is going to ask you for it, and when you put in 4, it's going to go wrong. So you just got to be real careful about that. Me, I'll give you partials. Okay, I'm not going to kind of completely rub because you're in college algebra now. So I gotta ding you a little bit. Well, then now I would probably do what?
Go down.
Yeah, I can go down and then go over, right? So down 2, over 1. What kind of slope is that going to be?
2x.
Down 2 over 1 is just gonna give me a -2. So doesn't that give me a slope? Doesn't that give me a formula now? So this is okay then. Y is equal to -2x plus 4. Is that good?
X.
Exactly. We are not dealing with y anymore. Okay, you gotta remember it's f of x. Okay. You good on that one? Now, another way to do it, notice you could have come in here and said this, hey, I've got a point here and I've got a point here. Well, that's gonna be what? 1, 2, and this is gonna be what? 2, 0. You got 2 points, right? Couldn't you find the slope from that? Take one of those points, use your point slope form, find the equation that way. Either way, because they might not give you something that crosses at a pretty point there. Okay, so be careful about that. Okay, on your homework. Oh, so hard, linear functions so far, right? And these have been something you've been doing since we masters at this. Look at this one. Find a linear function with the following properties. Now look at it carefully. While it looks really hard, what is the 0? What value is that? What am I replacing? X. So if that's my X value, if I was going to write this as a coordinate point, wouldn't I write that as a 0? And when I go to 0, what is it saying is at 0? What's my slope? Well, isn't 0 comma b, isn't that a what? Isn't that your y-intercept? So couldn't you write this as f of x is equal to what? Yeah. That's it. Remember, this is your x, and this right here is the y value at 0. Because that 6 is only going to be 6 when x is 0. Okay? That's how come 0 is the independent variable. Okay? Good? Look at that. Not horrible at all. Let's look at this next function here. Well, look at that one. Find the slope and the y-intercept. What? Now let me give you a little hint real fast here. Before, just in case, just so you know, you cannot do anything mathematically to him. Okay? So don't come in here and go, you know what I'm gonna do? I'm gonna get rid of the fraction. Okay? You can't do that. Okay, on this one, okay, per se. Because I can't come in here and who is using an ugly green color? That's what. I can't come in here and just all of a sudden start multiplying everything by 5. That is not doable because this guy right here, this guy is this. Okay. The definition of him is all that. So you can't be multiplying to him. Okay. So you can't get rid of the fraction. So you got to come back in here and do what you learned a long time ago with your rational expression saying, hey, I've got to create a common denominator. Okay. So whenever I look at this guy real fast, I can come here and do this. Go, okay. Well, notice you're seeing fractions, right? This guy right here, let's kind of rewrite this as 4x over 1 minus 7 plus 2x all over 5. Don't forget that parentheses. They're doing it for a reason. Well, what am I missing? Fractions. Think fractions. Common denominator. So how about I just multiply this side by what? Yeah. When I do that, notice I now have a common denominator and I can do this. I've got, well, hey, 5 times 4 is 20, right? So that's going to give me 20x. Notice that negative has now moved up into the numerator, so I have minus. Do not forget you have this 7 plus 2x here. So what do I need to do with that negative there? Exactly, distribute that guy. So then I have 20x minus 7 minus 2x all over 5. How about we clean this up a little bit more, right? 20 minus 2 is going to give me what? 18x minus 7 all over 5. When you have one denominator, what can you do to that denominator? Split it up. Well, let's look at this. Once I split that up, tell me what this turns into. I have p of x is equal to, hey, how about 18 over 5x minus 7 over 5? I don't know about you, but that looks exactly like y equals mx plus b right now. You end up having to do some math. You're going to do 18 divided by 5, which is going to give you, well, that slope right there is plenty enough, right? Okay, but you can find some points. Okay, to be honest, that guy's going to be really hard to graph. Okay, mainly because of the 18. Okay, so look at it carefully. You can go ahead and plug in points. Now, remember, you can plug in points if you're using a calculator. You can plug in any point you want. So let's look at this very carefully. For one, don't make it hard on yourself. If I'm giving you a graph, now remember we've got x, and then what am I going to put right here instead of y?
P of x.
P of x. Don't worry about you. If f of x is our go-to, I do it all the time. I have a function here. You know what I want to find? Hey, I need 2 points, right? Well, what happens whenever it's 0? Well, doesn't that make some easy math? Because anything times 0 is what? 0. Well, what's going to be left? Just the negative 7/5, right? Well, that's nice. Well, then how about another one? Let's do 2. Now you gotta be careful because you don't want to go off the graph. Okay, so let's try 2. Okay, come right in here, and you're gonna go, okay, P of 2 is gonna equal 18 over 5 times 2 over 1 minus 7/5. If you'll permit me now. Keep your knowledge of doing fractions in your head, but how about I come over here and once again, I'll show you how to do it on your calculator. I guess sometimes it may be quicker to go ahead and do it by hand. So notice I have this one. I'm gonna go, you hit, see that little second key there? I'm gonna make sure, not second key, I'm sorry, see that mode button? I'm gonna make sure that this is in math print. Okay? If it's not in math print, you're gonna keep getting decimals. Okay? It's not gonna work the same way. So I've got it in math print, hit clear. And so let's see here. I had what? I had, hit my little fraction key there, and I had what? 18 over what? 5? Am I right about that? Because I'm not looking at my notes. Times. But you can actually just put 2. You can actually just put 2 in there if you want to, but I'm gonna put 2 over 1. And what am I plus there? I'm minusing what? Minus 7/5. And I get, oh look, 29 over 5. Did it all for me. Okay, so I can come back over here now. Now let's be honest. 29 over 5 is fine. So I'm gonna put over here 29 over 5. I'll put it right here. 29 over 5. Well, I'm gonna be honest, I don't know what 29/5 is. So I would come back over here to my calculator and let me see if I can't get this thing to show you just a little bit better. It's not showing the bottom of my calculator here. Look right here on your calculator. See a little double arrow thing? When I click that, it gives me the decimal value. Okay, so I know 29/5 is actually 5.8. Okay. Now, could you figure that out on your own? You just do 29 divided by 5 in your calculator, obviously, but that kind of saves you a little bit of time. While I'm at it, I might as well figure out 7 divided by 5. I know it's a negative, but that's gonna be 1.4. So notice I actually have some values here. I have negative 1.4, and I also have what? 5.8. Now, look carefully. So I'm gonna go to 2. Okay. Or sorry, 0, negative 1.4. We good right about there? If you're graphing by hand, do you think I'm gonna take a ruler out and start measuring you? Get it as close as possible. I'm gonna be happy, okay? And then we're gonna do what? We're gonna go to 2 and we're gonna go up to 5.8. So 2, go up here to 5.8 is gonna be pretty close. So there you go. I'm pretty happy with that, right? And then you draw yourself a line. And there you go. That's how it's solved. Did we spend a lot of time getting hung up with fractions? No. Good. How do we feel about linear functions? Pretty straightforward, huh? Kind of the same thing you've been doing since you started learning linear functions back in intermediate algebra. Okay? It's just things look a little bit different. Maybe the math looks a little bit more ugly, but it still works out the exact same way. Okay? Hopefully you're not getting bogged down by the fractions. Please make sure that you're taking the time to practice whatever I'm showing you on your calculator, because it always kind of sucks to be doing your midterm and not know how to work the calculator. Okay. We good? Any questions before we move on? Well, just like in intermediate, we moved from linear and then we went to what? What do you think is coming next? What's the next function? Give you a hint. Big smiley face. Huh? Parabolas. What creates a parabola?
Quadratics.
Quadratic. Exactly. A quadratic. A power of what?
2.
2. Exactly. A quadratic is coming next. Quadratic. Once again, now we're dealing with quadratic functions. No longer are you going to see y is equal to x squared, blah, blah, blah. It's going to be f of x. The quadratic function f in the variable x, also known as a second degree polynomial function, which is important to remember. Second degree polynomial function is any function that can be written of the form f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a cannot equal 0. Tell me why, using your intuition. What would happen if a was 0? What kind of function do we actually turn into? If a is 0, doesn't that just go away and then you're left with what? A linear function. Okay, so that's why they're saying a cannot be 0. Okay, so looking at this, let's recall what it's going to look like in its base form. Notice, I want you to realize something. No matter what function comes your way, no matter how these equations look, this is the guy I'm looking at. This is how come we've been stressing about putting things in descending order. You always look at the largest power, right? Okay. And since I know this is a second degree polynomial, I don't care what's coming after it. Okay. That too tells me this is a polynomial function. Okay. This is a quadratic function with a second degree. So I know No matter what happens between here and here, if something happens and all of a sudden it goes tick, 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 and then goes back up, but there's still a 2 there, I have an idea of what the shape of this thing roughly should look like. So that kind of gives me an idea moving forward, okay? Remember, you can graph these very straightforward. Recall that you did learn about mapping these. They're mapping from the real to the real, but also they have a domain. But you could graph these very simply. You come right in here and go, okay, well, hey, I've got x and I've got f of x. When f of x is equal to just x squared. When x is 0, what is x squared? How about 0? See who remembers how to graph these. See if we can make it easy on yourself. When x is -2, well, what's -2 squared? Exactly. 4. What's really neat about a function, be honest about it, okay? If I could graph this right now, I can come over here and go, okay, I've got -2 and I come up to 4. Well, don't I have another number automatically? I'm gifted. What?
2.
2 to 4, because a quadratic function is what? It's a mirror image. You're gonna learn about what that mirror image means very shortly. Okay, and then all of a sudden, now we can keep going with this, but you get the drift of it, right? I can come in here now and draw better than I did. And could you keep finding points if you wanted to? But this, we've just now mapped every single point, right? And notice when I'm talking about that mapping real to the real, it's literally saying, hey, I put in a real number, what's gonna come out the back end of this guy? A real number. That's what's gonna come in. Okay, now this one has a domain. What's the domain of it? Yeah, so is there any restriction on this function? No, I can put whatever I want in there. So the domain is all real numbers, but what is my range?
To positive infinity.
What is that?
0 to positive infinity.
Yeah, 0 to positive infinity would be my range. And then the domain is, of course, all real numbers. And it's told you by the graph. You can see it. As I start putting in x values, I'm going to be getting these y values at the back end, and that's the shape we get. Okay. So, like I said, it doesn't matter what this thing looks like. If you get an x squared plus 2x plus 1, it doesn't matter. You know by seeing that x squared, even if it's 4x squared, you know that x squared tells you I'm going to have a parabola. I may have a thick parabola. I may have a skinny parabola. It may be a parabola going down. In some cases, it may be a parabola on its side. Depends on how they decide to define it, but that would be a function. Doesn't mean you can't graph it, but it wouldn't be a function. But it is still a parabola because of that second degree polynomial. That tells you automatically. Okay? A lot of the functions that you're going to start learning after this one, if you can take it back to the linear, the quadratic, and the radical, those 3 base ones that you've already learned, you can figure out the behavior of every other one, just knowing about what power is it. Okay? You'll see shortly, like tomorrow. Look carefully here. I'm going to show you some stuff. Everybody see the bottom of that okay? Okay. I want you to look at something here. Now notice that I've given you 2 different functions. I've got g of x is equal to x minus 3 squared. I know this is a quadratic because what tells me it automatically? The square. The power 2 tells me this is a second degree. I want you to start realizing something real quick though. Start noticing some things. If you solved this, because you can solve these, right? Just make it equal to what? 0. And what would that equal?
Positive 3.
Look where it's at. Make sense? Okay. So notice x minus 3 actually takes me to the 3. I say this because you're going to start learning about this. So when we start noticing things like this, have you noticed that's kind of how it works every time we've done things? When you have that minus in there, but you're gonna put in a positive, it ends up kind of like negating itself out. Well, here, now we're solving, so when x minus 3, well, that equals 0, so that becomes x3. So this thing, this whole parabola, while it is still a parabola, it did what? Just got moved over by 3. Notice what happened to the other one. If it says x plus 7, make it equal to 0, well, that's just gonna be what? -7 there. So we're just kind of showing you what they can do. Okay, how you can kind of move them along. You can even go up and down with them. You've done that. That's depending on what the x-axis says, right? Okay, or sorry, what happens on the y-axis? We call these translations. You're going to learn these a lot more. Look at this next one here. I have two. I've put them all over here, but notice I have another function. I have j of x. Well, do you remember the last one? How we had like that x plus 3, but then I surround and put squared. But notice how this one, I just give you x squared, but notice I do plus 5. Well, notice at plus 5, what happens? It moves up. Okay. Notice at minus 2, it moves down. And you could actually combine these. You could have put x minus 3 there, squared, plus 5. Well, x minus 3 couldn't have just moved it over and then done what? Move it up or down. You're going to start learning all about this. This is kind of like a prelude of what you can start doing with quadratic functions. You can make them wider. You can make them smaller. It all depends. Wider, that's your A. Look at it here. I get it just right here. What's happening to the function when A is greater than 1? Right here. Is it getting wider? Or is it getting smaller? Yeah, it's getting kind of more skinny, isn't it? The larger this thing goes, the skinnier it is. Think about it. Why is it doing that? This is still, I'm going to use a very base term. This is not exact math, but this is like having a really big slope. Okay? Imagine if I gave you the slope of, say, back in the day of m is equal to 10 over 1. Bro, you're going up 10 over 1. That's a pretty steep slope. So that's actually where m is just equal to what? 10. As that number gets larger, that slope gets more and more and more. As it goes down, it gets what? Wider, wider, wider. It's the same thing here. The larger this number gets, skinnier that parabola is going to get. Anything greater than 1. Whenever it's 1, you just got x squared. It's going to be the base x squared. Now, if we start getting less than 1, that's when you start having a thicker, okay? Notice what's happening here. Look at this. It's getting wider and wider and wider, okay? And also, when it's a negative, what happens? It moves where? It flips across the x-axis, okay? Are you with me? Not too bad. Some of this you kind of know. Some of you're kind of going, oh, okay, makes a little more sense now. I mean, you probably just graphed a lot of them back in the day, but now you're seeing why. Like, as you start to look at these, okay, well, as you move through this class, I want you to be able to look at this and go, okay, I've got 2x squared plus 3x plus 2. Let's make it even worse. I've got 10x squared plus 3x plus 2. You know what? I don't know exactly what that thing looks like, but I will tell you this. It's a parabola going up because my leading coefficient is positive. It's going to be super skinny because that 10 has made it super skinny. And I do know, wherever it is, it's going to be moved up 2 because of that plus 2 on the back end of it. Notice that's before doing any math, anything at all, that you could kind of give yourself a rough sketch on what that function looks like. Now you want to get exact, you graph it, right? You start plugging in points. But until that time, you're just sitting there just kind of going, okay, here we go. You have an idea. Good? Got it. Vertex form. You've all heard of vertexes. The graph of the function g of x, now this is vertex form, okay? I did not teach this to you in intermediate, okay? I want you to know right now, you can put this into vertex form or you can use the vertex formula, okay? Vertex form is not hard. I'll show you how to do it, okay? But you do need to know how to read it no matter what, because some things are going to be given to you in vertex form, okay? So read this carefully. The graph of the function g of x is a, there's that constant, x minus h squared plus k, where a, h, and k are real numbers and a cannot equal 0 again, is a parabola whose vertex, remember vertex, it's either going to be the highest point on that parabola or the lowest point. It depends on which way it's going, right? Where h and k, okay, that's the vertex. It's already given it to you. Okay? They're already giving you the vertex in the formula. The parabola is narrower. Maybe eventually I learn how to speak. You got to hear me on church on Saturday. I had to read some big old like Hebrew words, and I was like, oh, here we go. And I taught that class, and I was like, you said I would have practiced before I got to church today. I didn't. I went, here we go, everybody. I have replaced it with the word Scott before though, so. F of x is equal to x squared. We just learned that if, okay, the absolute value of a is greater than 1. Remember, larger than 1, it gets skinnier. Broader if it's less than 1. Or is it between 0 and, okay, to be exact, between 0 and 1. The parabola opens upward if a is positive and downward if it's negative. Okay. Let's look at this carefully. 1. Vertex formula says this. I'm going to give you the formula for a vertex, okay? But this is just going to be of a base function, okay? Then here it is. There's that f of x. Negative x squared minus 2x plus 3. Okay, you with me on this? You ready to take some notes? What I always do first, A, B, and C, always, okay? Vertex formula is this. 1, and you're going to be using this a lot, okay? Is going to be x is equal to negative b all over 2a. You should remember that. I have taught that to you before. If you had me, you learn this, okay? You have to solve, and then you plug it back into the equation to find your y value, okay? So let's kind of just do this very quickly. Notice I have my b is going to be negative 2 all over what? 2 times a. Well, that's going to be 2 times negative 1. Negative and a negative make a positive. That's going to give me a 2 divided by negative 2. That's going to give me a negative 1, correct? Okay, that's your x value. Are you with me? That's my x. So you're going to come over here and put negative 1. Because now you have to come back in here and take that function. I'll write it in blue right beneath it. You're going to take this f of negative 1 and plug it all back in because you need to find your y value now. Remember, the vertex is a coordinate point of a parabola. For this one, we know the parabola is going up or down. Huh? Down. Why do you know that?
Negative.
The negative, that negative leading coefficient, that negative 1 says I have a parabola doing this. So my vertex is going to be the highest point since we've got a negative parabola, okay? So I've got to plug everything back in. So notice I'm going to have negative 1 squared minus 2 times negative 1 plus 3. That's going to give me negative 1 plus 2 plus 3. which is going to give me. Should get a 4. There's my point. Now that's one way to do it. That's to find your vertex. So notice I can come in here and go, okay, sweet. At -1, 4, I have that. Now what if they say, hey, give it to me in vertex form? Here's how you do it. Do you remember, now I'm not saying how to do it, but do you remember completing the square? Remember how we did that? Okay, we're gonna do the same thing. Watch carefully. It's almost exactly the same, almost. To put it in vertex form, which is gonna be of the form, I'm gonna put number 2 here, where f of x is equal to a x minus h squared plus k. This is what we do. Okay, I have this function right here. This function says negative x minus 2x plus 3. You cannot have that negative out front. Are you with me on this? Cannot. So the first thing I'm going to do is this. I'm going to pull that negative. Now be careful. Watch how I'm going to pull this out. I'm pulling the negative out. I'm going to factor it out of just this spot there. Are you with me? When I pull that negative out, this guy inside here is going to go to what? X. Then he's going to go to a positive x. And then I get a plus 3. Good so far. Now, remember completing the square, or sorry, yes, completing the square says this. I'm going to take this guy right here and do what? Take the 2 divided by 2 because we're taking it by half, right? 2 divided by 2 is 1, and then we square it, and that becomes a 1. Now watch what's going to happen. I'm taking this 1, I'll do it in red. I'm going to add 1 in here, and I'm going to add 1 right here as well. Air conditioning. Are you good? Look what this is going to create. Let me kind of come over this way. I've got this negative here. Inside here, and I'm sorry, I forgot to put the 2 in here. Don't forget to square that. Write correctly. X squared plus 2x plus 1. 3 plus 1 is 4. Well, we're almost there. Good? Okay. Now look at this. Come in here, and remember, this guy's going to factor into what? X plus 1 squared, okay? Plus. But I want you to realize something. You might be looking at that going, well, how'd you get that -1? Remember, the formula says what? There's a negative there, right? I have a positive right there. How to get a positive? Got to have a negative. So there are my points right there. So the point, once again, is going to be -1 and 4. Because there is going to be my H and my K. My H and my K. Now you haven't really graphed anything yet, but here's what's nice about, now here's what I do like about vertex form. Okay, watch this. You're pretty close to something. So let me go ahead and rewrite this. I've got what? I've got negative x plus 1 squared plus 4, right? And don't forget this is we're using f of x, yes we are. Well, realize you're dealing with a parabola, right? So I can make it equal to 0. So I can get negative x plus 1 squared plus 4. Well, how about this? all equal to 0. Subtract 2 from both sides, I get negative x plus 1 squared is equal to negative 2. Divide off the negative 1 on both sides. I get x plus 1 squared is equal to 2. Well, how about I just take the square root off both sides?
Supposed to use a 4.
That's a 4.
Oh, sorry. I'm getting ahead of myself. What happened there? Doo-doo-doo. Where is it? Oh. Down in here, 4. 4 and then 4 here. Well, then notice now, there you go. Then I get x plus 1, what? Is equal to plus or minus 2. We kind of come up here around our room. So then I get x is equal to negative 1 plus or minus 2. Which does give me what? Well, negative 1 plus 2 is what? Isn't that just a 1? Negative 1 minus 2 is a negative 3 and decimal points. Those are your x-intercepts you just solved for. And you used the square root method to solve it, to find your x-intercepts. So that's what's nice about this formula here. Just gotta be careful though, okay? I do like it. Do I use it a lot? Not a lot. But you need to know when to see it, okay, and how to read it, okay? Another one. Here we are. I'll leave this one for you. Find the formula for the quadratic function below. Let's see. Notice on this one right here, you can look at this very carefully. I'll show you how to just do this very quickly. First off, whenever you get one of these on your homework, one, find the x-intercepts. Well, notice I have an x-intercept here and I have an x-intercept there. That is where x is equal to what? Negative 2 and negative 4. We all agree with that? Well, realize then I have this then. If I want to put this in a form that I understand, okay, you still don't know if this thing has a leading coefficient or not. So I'm going to write it like this. I'm going to find f of x is equal to a, don't forget your a, and realize this is going to be x plus 2, x minus 4, right? Because to take them back, sorry, x plus 4. Take them back in time, right? Because to get to the negative 2, how do I have to do? Make it equal to 0, go back the other direction with it. Find f of 0. Okay? F of 0 is going to be this. Okay, you've got a little form here. When I look at f of 0, notice we don't worry about the 8 right now, but I can come in here and do this. Hey, 0 plus 2, 0 plus 4 ends up being 2 times 4, and that's going to equal 8. Are you good so far? So look at it this way. Now that I have that, let's do this. You come in here and you've got this 0 plus 4, 0 plus 2. All of this is going to equal 8. Okay? Don't forget your a. Do the math. A to the 8, right? Did we just figure that out right there? Is equal to 8. Divide off the 8. A is equal to 1. So your leading coefficient is going to be a what? A 1. Because we solved for the 8. Okay? When f is 0, it becomes an 8. And so that's how come when we plug everything back in, you got that a is 8. Okay. Come in here, you FOIL all this guy out. So when you FOIL, I'm trying to do the quick math on that. You get f of x is equal to x squared plus 6x plus 8. Don't need the 1, right? So make it equal, find out your guys, find your x-intercepts first. Let that be number 1. Number 2, make it equal to 0. When x is 0, what is it going to equal? Just plug in back your 0, you get an 8. Okay? Now you're making the whole thing equal to 8. Don't forget your a from your original part right here. Okay? And then just solve. Solve for a at that point. That's going to let you know what your leading coefficient is, whatever it may be. Okay? And then you can always go back to the original. Let's do a couple more. Maximization and minimization problems. Word problems. Okay? Maximizing, you're going to have a negative parabola. Because what's happening? Look at it. This guy right here is coming up. He's coming up, gets to its vertex, and then does what? Goes back down. You want to maximize land area. If you want to maximize profits, they're going to give you a formula and go, what is the maximum amount of profits? Well, when you hear maximum or you hear minimum, vertex. Just think vertex. All you're doing is using a vertex formula. Going, okay, what is the biggest point up here? Okay. And there you go. And then something's going to be related to something else. The x value may be, hey, if we're using sales, it may be say, hey, x is your sales, b is the number of products. Okay, or y would be the number of products. So when you solve for that vertex formula, you go, okay, to maximize profits, I need to sell 5 of these things at this price, or sell this price and this many of them. Okay, that's what it's doing there. Okay, same thing with a minimum. How do I minimize loss? You're finding the vertex again. No matter what, you're still looking for a vertex. Now, there is a way, instead of having to find your vertex, remember you kind of been doing that. You find the vertex of the x value, the negative b all over 2a, and then you have to plug it all back in. Well, you wanted one more formula. There's a way to do it. Look at this guy right here. The total revenues for Dante's Villas, and this is going to be our last one, is given as the function r of x is equal to 500x minus 0.5x squared, where x is the number of rooms booked. It tells you what number of rooms booked produces the maximum revenue. Well, let's first off rewrite this as r of x is equal to, get it in the proper form, negative 0.5x squared plus 500x. Realize also we have an a and we have a b. What do we not have? A c. Okay? Look at what's about to happen here. I'm going to give you a whole vertex formula for a coordinate point. Vertex formula for the whole point. If you have something of negative b all over 2a, can we all agree that's the x value? Comma 4ac minus b squared all over 4a. There's your y value. So literally you can plug everything into the formula, can't you? I'd come in here and go, okay, well, how about knowing that this is my x value here, this is my y value. My x is the number of rooms booked, and it's asking me what numbers of rooms booked produces. So really, do I need to figure out everything? No, I only need which part of this? That guy right there, right? I will show you though, it's pretty straightforward. I can say this, hey, how about I replace that as negative 500 all over 2 times negative 0.5, comma 4 negative 0.5. Now you don't have to do this part. 0 minus 500 squared times 4 negative 0.5. Easy calculator work there on that next one, right? Come in here, once you put everything in your calculator, you get 500 rooms and then 125,000. But the question is saying this, how many rooms do I need to book to maximize my profits? 500 rooms. How many people have ever run a business and just said, oh, the more I sell, the more money I make? That's not true. There's called optimization problems. There's actually an easier way to do it, once again, in calculus. Okay, unfortunately, you get to learn the long, ugly math. In calculus, it's literally just to look at it and make something equal to 0 and you're done. Okay, but it's saying at 501, you're actually going to start losing money. So the more you sell, you're not making more money. The more you sell, you're going to start losing money. So sometimes when you see these new restaurants open up, they're like, man, they're so busy. Why did they shut down? They didn't optimize. They didn't find out exactly what was the optimum amount I need to sell. Okay. And pretty much everything else after this is exactly working. All your notes will be working the exact same. So how do you feel about quadratic functions? Pretty much the same thing. The vertex form looks a little bit differently. You can use it either way, that vertex form where you got the A, okay? Just know how to read it. Remember, it's the H and K. It's the same thing you learn when you learn circles, right? Remember the H and K was the what? Anybody remember what the H and K was in your circle formula? Exactly, it's the center. Remember? It was the center of it, and then it was equal to the radius. There you go, very good. But they still used H and K. So we haven't really changed definitions, or we just kind of changed the way the function looks now. Okay? Now you don't have to get things into that vertex